Okay, I'll go first. I'll break the ice. My name is Clara Romero. I'm an urban
Okay.
designer. What the ideas are here.
Sorry, Clara, I think we lost you for 90% of what you just said. It just froze right at the beginning. Yeah. Oh, yes, we have.
Okay, so I'll repeat myself.
Okay.
Can you hear me?
Yes, you're good.
Yes? Okay. Hey, my name is Clara Romero. I'm an architect and an urban designer, and I work at Perkins & Will. Most of the projects I work on are master plans, streetscape.
Okay, we got more of it that time. We got more of it, still cut off about, I think, halfway through, unfortunately. Yeah, so I don't know if you want to give it one more try for the second half, or if you want to move on, that's up to you.
I think we can move on. Okay. I'll write something in the chat, and hopefully that works.
Okay, awesome. Yes, so we have our fourth judge here as well, and the client now. So yes, judges, if you can continue introducing yourself to the students, that would be awesome.
Maybe I'll be next. My name is Silvio Miron. I used to work for the University of Ottawa over at Facilities, and now I'm working for, hey John, and now I'm working over at Parliament Precinct as a team leader. I've developed with some co-op students, engineering of the University of Ottawa. We worked 2 summers straight on the impact of salt on our infrastructure. And we had very good results from the last summer group. And I'm really anxious to see what our students are presenting today, because I think it's a continuity of 2 years of working with students. So I'm happy to be here today.
So I'm happy to follow. I'm happy to follow up. Can you hear me okay, kind of? Yeah, so my name is Al Perks. I'm the engineer in residence at the University of Ottawa in the Department of Civil Engineering. I graduated from UNB, which is a great school too. I put that in. I spent most of my career in consulting as a water resource engineer. And I worked across Canada and around the globe, including India, China, Southeast Asia, East Europe, and so forth. So it gave me a good perspective on relatively how well things work when they're properly operated and maintained.
All right, so I'll go, oh, sorry. Okay, I'll go last. My name is Oliver Zhao. I'm a civil engineer working on infrastructure project, especially with the municipal and provincial infrastructure. And I work a lot on sidewalk applications. So I think I'll have some great questions for you guys later. And also, I'm actually invited through by OSPE, the Ontario Society of Provincial Engineers. I'm the current chair of their infrastructure task force. And I also sit on the board of the PEO York chapter here in the GTA.
Okay, thank you to all the judges. We're really, really happy to have you here today. And I'm sure you'll all have great insight on the projects. John, I think most of the students already know you, but I don't know if the judges do. So if you want to go ahead and introduce yourself, that'd be great.
Sure. Hello, everyone. I'm the client. My name is Jonathan Rosseo. I work at the Office of Campus Sustainability for the University of Ottawa. A lot of you probably don't recognize, it's more like it. It's probably more recognizable for the students. I'm usually wearing my hat. It's late at night when we're talking, or midday or something. I worked with Silvio Miron a couple of years ago on some salt projects. We saw how impactful it was on campus, and so when I heard that having students make prototypes was a thing, I had to get involved. And so I'm really happy with the progress I've seen over the year. for all the judges, the idea was that the salt is corrosive. It's destroying our sidewalks, it's destroying our staircases. And so we asked the students to be able to fix my problem for me. And so I think that's what they're going to be presenting today. But I'm really excited to see what everyone's got.
Okay, thanks, John. And I guess final thing before we can get started, I have my little speech. Starts out with just making sure that all the judges have access to the evaluation form. It's a Google form where you can enter your grades for each group. John, you should also have a client evaluation form. You have that, perfect. Okay, so everyone, for judges and clients, we'd prefer it if you have it in speaker view, just so that if the students are switching from screen sharing to showing their prototype using a camera, then it'll automatically do that for you and you don't have to worry about pinning anybody. So if you're having any trouble getting it into speaker view, just let me know and we can go through that. If everyone doesn't mind, because we're doing speaker view, just staying muted until the question period, that would be awesome as well, just so that the camera isn't jumping around too much. It's focused on the students who should be talking. I'm also going to be monitoring the chat, monitoring everybody's cameras, just in case anything inappropriate or unacceptable happens. Just a warning to everyone, not so much the judges, we need you here, but the students and guests, if anything happens, I will definitely be kicking people right away. Not too many warnings are going to be given. So just keep that in mind. Okay, and the last thing is just to remind the students, it's 3 minutes of presentations, 5 minutes of questions. We are already running about 25 minutes behind, so unfortunately I'm going to have to be pretty harsh about the 3-minute cutoff time. So if you get to the 3 minutes, I'm just going to jump in and let you know that you've hit the 3 minutes, and then question time will be open. Judges, if somebody gets cut off, you do have the option of asking them to finish their presentation, but it's going to come out of their 5 minutes for questions. And for the question time, we like to give judges the first chance at questions, just because it's going to help them better evaluate the groups. But if they run out of questions, anyone is allowed to just start asking questions that they may have. John, if you have any groups that you want to speak to afterwards, just let me know, and I can send you to a breakout room with those groups so that you can get some time to talk to them as well, just in case we run out of question time. Okay, so with that being said, I believe F1 is the first group to present. So whenever you're ready, you can just start screen sharing and let me know and I'll start the time.
Okay, I'm just gonna share my screen. I think it's this one, yeah. Can everyone see well?
Yep.
Yeah, okay.
Yep.
So Aiden, whenever you're ready to start.
Okay. Welcome everyone. My name is Aiden, and today I will be presenting here with my teammate Aislinn to talk to you all about our project Ultimat. Our modular heated sidewalk design understands that safety is of utmost importance, considering it will be providing a new surface to combat icy or otherwise slippery walkways. We built a simple yet resilient design featuring an insulated heating wire with a built-in thermometer to detect when the surface experiences low temperatures and heats up accordingly to melt any snow or ice. We then allocated our remaining budget to safety features, such as an elevated non-slip segment on nitrile surface to not only provide a safe surface to walk on, as well as providing wheelchair accessibility, but also to drain any water through channels in between the strips. Connecting and iterating Ultimat is made simple, with optional connecting pieces that fit into grooves underneath the walking surface, eliminating any potential tripping hazards between tiles as they stick together to span larger sidewalks and surfaces. Sidewalk tiles can be easily powered alongside one another in parallel, with the use of power bars or extension cords, meaning that potential damages to one tile will not harm the effectiveness of neighboring tiles.
The temperature sensor is embedded on the bottom of the mat and raises the surface on the side power is drawn from. This slant allows for water to flow away from the buildings and onto the road, as well as prevent water from pooling on the walking surface. Ultimat is also designed with acrylic supports on the bottom to protect the wire from getting damaged, as well as support the weight of pedestrians. The mat was tested at -3 degrees in a shaded area with crushed ice to simulate a snowfall. When looking at the 3 photos with different timestamps, it is seen that Ultimat can melt large ice cubes to a reduced size, as well as melt small pieces of ice completely. Under the available test conditions, we can see that Ultimat effectively melts snow and ice, proving to be a more sustainable and overall better alternative to road salt. That's all we have. So we're open for questions. I also do have the sidewalk behind me, like the prototype, if you want to see it better.
Okay, thank you. Judges, take it away for questions.
So question number one from Al. What were your considerations with regards to wheelchair accessibility in connecting this part of the sidewalk to other existing parts of the sidewalk?
Okay, well, our sidewalk design, we have the grooves underneath the bottom with the connecting tiles so that the two sidewalk tiles will fit together very smoothly and not have any ridges in between. And the water channels in between, we made sure that they were at a distance apart from one another so that no wheels or shoes or anything can get stuck in them when they're traveling over top. And the connecting pieces that connect the sidewalks together are optional. So on the edges of the sidewalks, you don't have to have them at all, and the sidewalk will just lean down to create a slant when you're entering or walking off the sidewalk.
Good.
Maybe a quick question for me. How do you tie the system down to the sidewalk? Is it very heavy, or does it tie with nails or with?
Well, on the bottom of our sidewalk, we have acrylic supports with waterproofing adhesive over top of it, and it's created to ideally, fit into grooves of existing sidewalks or just create some sort of like friction between the sidewalks in general. The sidewalk tiles, ideally, they're somewhat heavy, so they don't slip naturally, but they're easy enough to pick up and carry around. But ideally, the more sidewalks you stick together, the more reliable it is that they can't slip with the more surface area.
It's Al here again. What's the temperature range you think your sidewalk system is capable of handling?
Well, the wire that we used stated that it could go as low as -40 degrees, which may be a bit excessive, but the operating temperature of the thermometer may be around maybe -20 degrees. We haven't had cold enough temperatures to really have extensive testing since we obtained the wire.
But the wire is just part of it. It has to heat up the rest of the plastic that forms the actual piece, correct?
Yeah, the wire has a temperature sensor built in that is embedded in the sidewalk, so it detects the temperature of the surface rather than the ambient temperature outside. So as the temperature cools down, the wire knows to heat it up.
So I'm simply thinking the wire can be quite hot, but an inch away, the plastic could be much colder because it's so cold outside. Was that a consideration? The movement of the heat through your device between wires.
I suppose that could be a concern. With our test, we haven't noticed any issues with something like that. We were ideally considering that the temperature of the surface of the sidewalk detected by the temperature would continuously heat up the wire until the surface is also just as hot.
Good.
And what temperature does it get up to before it turns itself off?
About 5 to 10 degrees Celsius.
Mm-hmm.
What are your expectations on durability for the product? Is this something that I'm replacing every year, every 5 years, 10? And also, how do you see the plastic resisting abrasion, for example, if somebody puts salt by mistake and so on?
Well, we used, with our rubber mat that we used, it seems very resilient. We've only had it for a short amount of time, so we haven't had a lot of damage testing on it. But it's very smooth and hydrophobic. Ideally, anything that has water running on it or salt water will just run right off. The ice melting tests that we have had water just run right off it very easily instead of building up.
One question from me. What's the snow melting capacity. So how many centimeters of snow until you need a snow removal operation?
In our prototype testing on our final slide, we showed we showed some dusting of ice chunks, and we were using ice chunks to simulate snow the best we could. We've only had one cold day since the completion of our prototype, but I with the dusting that we provided to try and simulate maybe about a couple centimeters or so of snow, if that sounds right, Aislinn, melted in about 5-10 minutes, and larger chunks took a little bit longer to decrease in size.
Okay. Sorry to cut you off. That's the 5 minutes for questions. Thank you very much, Team 1. Excellent job. The next team is Team 4. So judges, I'll give you a few minutes to finish up filling in the evaluation. And Team 4, during that time, you can set up your screen sharing or whatever you have to do. And just to keep everyone updated, we're about 15 minutes behind right now. So you can expect to start somewhere around 15 minutes after your scheduled time. Okay, and judges, if you don't mind just maybe giving me a heads up once you finish your evaluations, that would be awesome.
Yeah, I'm done.
I'm done as well.
Oh, good.
Yep. Okay, I'm good, Kyla.
Okay, in that case, sorry, just let me get the timer set up, and F4, you're good to go whenever you're ready.
Hi, we're Group 4. We're not Salt, and I'm joined here by my group members Armand and Paul, and I'll leave it up to Paul to kick us off.
All right, hello everyone. As mentioned, we are not Salt, and I'd like everyone to do a little bit of visualizing for me. All right, so picture this. You're living in Canada and heading out on a cold winter's day, and you walk through the snow, you look down, and suddenly you realize, to your horror, your shoes have been destroyed by salt stains. You might think that this is as bad as it gets when it comes to salt, because now you gotta buy new shoes. But this is just the tip of the iceberg when it comes to using salt to melt ice. As it turns out, salt is a huge reducer in the lifespan of infrastructure. For example, at the University of Ottawa, it can reduce the lifespan of our infrastructure by up to 25 to 50%. And not only this, it can also damage nearby greenery and be toxic to wildlife. So my team and I wanted to come up with a solution to replace this chemical.
To combat this, a lot of companies have tried to create heat mats. Unfortunately, many of these heat mats are not automated, are not modular, and require constant repair and replacement of parts. So as you can see, there's a lot of issues that need to be tackled and understood when creating a heat mat. I'll leave it off to Armand to go into how we chose to tackle these issues.
So our design for the NS heat mat is a modular sidewalk cover where it's easily expandable via the use of dovetails, so it can be extended on a variety of different surface areas. It can support well over 180 kilograms, which is about the weight of 2 people. There are several holes placed throughout the center of the heat map to allow any melted ice and snow runoff to flow to the bottom of the mat to avoid any accidental ice formation, and it allows the water runoff to actually flow down to designated manhole covers. And then finally, with using the Tekken Smart Plug, we can automate the system by having it being able to turn on and off via remote application, as well as be able to set timers and allow the user to control it whenever they need. Here is a quick demonstration of our product working. Because our product uses an insulated heated wire with a temperature sensor, we needed to just submerge the temperature sensor in an ice bath. The inductive wire will turn on when it reaches about 3 degrees Celsius. And I would just like to let you know that these are not the final materials we will be using for the final product, as wood is an insulator. But as you can see through the demonstration, it is about half as effective as if you would be just melting ice on its own, as you can see from the control variable ice cube on the left or the right side. And with that, I'd like to thank you for listening to our presentation. And if you have any questions, please let us know.
Okay, so the 5 minutes for questions has begun now.
I was just going to quickly ask, what you said this wasn't what you were looking for in terms of the final materials. What materials were you thinking of using for the final product?
So we would like to add metal bracing just to help add more security and rigidity to the mat itself. So that way it's more wear and tear proof for long periods of time, as well as it would allow better, you'd use materials such as a small metal plate on the top as the top cover with a bit of insulation just to control how much heat is being transferred through the mat. So it doesn't bring any it doesn't hurt any animal or wildlife that would be walking on it by getting into just like slightly too hot.
So to build on that question, what does it look like with this finished material?
So it would be the same design as shown in the picture present right now on the screen. We would likely use more rubbers, and so like for the internal columns there, it would be rubber so that can transfer the heat and ice, it'll avoid ice formation inside the mat. And then there'd be just metal bracings along the dovetails so that they don't get worn off as quickly.
Yeah, it's Al here. Just wondering, where do you see this being applied? Like, is it on a home sidewalk or entrance to a restaurant, or do you see a wider application of this?
We believe that we can use this application for both sidewalks and general pathways or building entrances, as it can be expanded in as much as you need it, as long as you need, and as wide as you need.
I'd like to add to that a little bit in that we also designed it so that the mats are strung together in a way that they're all powered by, or not all powered, but many of them can be powered by one smart plug. So at the touch of a button on your phone, you can turn them on or off in different locations depending on needs. So it's really applicable to a wide variety of scenarios.
I see. What would be, have you considered the energy use per square meter of this? I mean, if you start installing these things, how much energy are we being used, which in itself is a significant source of pollution?
Well, to answer that, I would like to offer a comparison we found from benchmarking, in that each mat that we found tends to take up about 300 to 320 watts of energy per mat. And while this is, I believe, the final design is slightly larger than a square meter. So we would probably be taking up about a comparable amount or slightly less. So I would say approximately 300 watts per square meter as well. And with many of them chained together, it would require far fewer power outlets than mats. So the power requirement would not be as high as you may think to cover a wide area.
Okay, maybe I have a question on my side. As you approach buildings, you face staircases and steps. Have you thought about how you would be molding this module to a staircase? Because I've seen one of the picture earlier in your presentation. I could see your mat placed on a stair, on a step. These are wide or big, and how do you attach these so they don't move or they don't slip?
Well, if I'm to answer that, I would say that we did discuss other shapes and other sizes for the model. However, because we were only building one prototype for the course, this is the one we used. However, you could, in theory, adapt this to a smaller size and place it on staircases. We could even attempt to make inclinations for wheelchair accessibility. However, this was not the main focus of our map. We were just looking to create a general prototype that would function for most scenarios, and if given future opportunity, we would like to apply it to specific scenarios later on.
Okay, thank you very much, F4. That's all the time for questions. Judges, you can start your evaluation, and the next group is going to be F5.
Okay, I'm done, Kyla.
I'm finished as well.
All good.
All good here too.
Okay, awesome. In that case, F5, whenever you're ready.
Okay, let's get started. Today, myself and Thomas are going to be showing you a product our team has been coming up with over this last term to be an alternative to salt. So what we have done is we came up with a heated sidewalk to lay on top of the current sidewalk in panel style. So in each panel, we split it up into three main sections, being the assembly, the drainage, and then the electrical and heat. So for the assembly, we knew it was very important to us that safety was a high factor. So we have traction on the top surface, as well as a ramp up to the surface to get onto it. We also have a drainage system in place to take away any surface water. And then the heating wire itself will generate enough heat to the top surface to melt any snow or ice on the top surface. I'll now show you a video of this in action.
So for our design, we wanted to focus on the drainage. It's really important for the safety because if there's water on it, you're going to slip, it can mess up the electronics, and it's just not a good thing to have. So we spent a lot of time on that, and it prevents the buildup of ice. If you could go to the next slide, please. We wanted to make it modular. That allows flexibility when you're using it. We can put it wherever we want. It's easy to maintain. The lid comes off so you can deal with the electronics if anything goes wrong. And we wanted an on, off, and an auto switch. And then I can show you the design. Sure if anyone can see it. But the wire goes underneath, so it helps with that. You can see the drainage inside. Hold it right, so the water comes out of the white pipe. And then this is the box with the electronics. And that's it.
Okay, perfect. Just at 3 minutes. So I'll go ahead and start the timer for the 5 minutes of questions.
Hi, I was wondering, so about how thick is your final design going to be?
Okay, so this one is about 3 inches. I live about 6 hours away from Ottawa, so I didn't get to use the makerspace. Moving forward, we would use acrylic actually, and it would be 1.5 inches. So it's kind of hard to see on camera. There's like a black pipe in there. I'm not sure on the top right there. There's 2 on top of each other, so it'll be half that size. We would just use the top of her. So 1.5 inches.
How is this intended to be installed? Is it embedded in concrete, or what is the system?
So it'll be a lot thinner, so it will go on top, and we're gonna have connectors. You can see on this side of it, we'll have 2 there, and then they'll kind of go together like Lego blocks. And then that will keep it together so it doesn't slip around, and it'll go for as long as needed.
So if it's sitting on top of the sidewalk, how are you doing the ramping up to this system when it meets an adjacent existing sidewalk?
Another sidewalk. We're gonna have the same material as the top, but it's gonna be a ramp, and being thinner, it won't be as much of an incline.
Do you see this more like a permanent solution, or you install it in fall and then you take it off in April and you store it away?
That's correct. Just for the winter months.
Okay.
How thick is it actually that you envisage the final design? How thick would be each unit?
1.5 inches tall.
1.5 inches. Okay, that's not too bad. So, and what's the energy use you're thinking about for this?
With the wire we have right now, it's 28 watts per panel.
Mm-hmm.
So we could connect approximately 50 per regular 15 amp circuit.
So, and what's the area of your panel? 28 watts per what?
This one is 15 inches by about 18 inches.
15 by 18. Yeah, so what's that, half a square meter or something like that?
About that.
Roughly, yeah. So you're talking about 50 to 60 watts per square meter to do it.
Correct.
Okay. Yeah, okay.
Just another question. You have all the drainage system inside your panel. Have you thought about not having the drainage system inside? Because then after a certain length, 100 meters, you still need to get rid of the water. Where does that water goes out to?
So there's a white pipe here for now. That will end up going into the sewers. So you won't have that on every panel, but every few panels, just to try and get it out, because we don't want the water there for anyone to slip on.
Are you using any very costly components?
The most expensive was the heating wire. It was about $30. I can show you. This is the electronics. So it's got a rain and a snow sensor. And this was all relatively cheaply made. The Arduino was the second most expensive, but one of these will do about 50 panels.
And I guess you can control this with an application, a phone.
In the future, we didn't with the budget right now, but it will be easy to implement. The Arduino is already there, so it wouldn't take much.
So the way you have it designed now, it's activated, like you turn it on and just leave it running?
So you can turn it off by unplugging it. There's a sensor where if it's below about 4 degrees and it's snowing out or there's rain, it will turn on. So there's that. And then if there's too much snow, there's an override. So you can keep it, someone can go to the box. There's a switch on the front right here. And down's for on, like override, and then that's the sensors.
Thank you very much, Team 5. That's right at the 5 minutes for questions. Great job. So the next group will be F7. Judges, just let me know once again when you're finished.
I'm done on my end.
Me too.
I'm good also.
Me too. Kyla, just tell me again so I don't mess it up. That was team F5, right?
Yes, the one that just finished is F5.
And the first one was F what?
1.
Okay, and the second one F2?
No, the second one was F4.
F4. I knew I did a little bit off there. Okay, thank you.
No problem. The next one is F7.
F7, okay.
Okay, so F7, whenever you're ready, you can just go ahead.
All right, thank you. Hello, judges, and welcome to Team Lucky 7's design presentation for the modular heated sidewalk mat.
At the University of Ottawa, road salt has shown major negative impacts both on the environment and infrastructure. Buildings have shorter lifespans, sidewalks and entrances need to be replaced more often, and salt seeps into soil and kills plant roots. Fixing these damages is very expensive. Our alternative is electric mats. To maintain the time-efficient qualities of salt, we have created a mat that is remotely and automatically controlled and isn't destructive like salt.
We created a website that connects to local weather networks to use its snowfall data. Then the website communicates wirelessly with the mats to turn them on or off. The desired temperature is automatically controlled by an internal sensor, and the automatic weather control can be overridden on the website with on or off buttons as shown. Our website is intended to be intuitive and easy to use. We have a both desktop website and a mobile app that can control each mat on the network remotely.
All of our materials are functional over big temperature ranges, which is important for a heating element subjected to Canadian winters. There are eyelets in each corner to fasten the mat to the sidewalk to prevent it from moving. We also raise the middle of the mat so that when the snow is melted, water rolls off the sides. For the heating element, we use nichrome wire for its durability and resistance to oxidation.
One of many advantages of our design is that only one Wi-Fi module is needed to control an entire section of mats, lowering the cost. There's also a temperature fuse that reduces fire hazards by turning off the mat if the wired temperature reaches over 40 degrees Celsius.
As far as electrical mats go, a lot of options already exist, but these are physically controlled mats. It would be inconvenient and time-consuming for university staff to run around and turn on every single mat when it starts to snow. Our mats are designed to require much less time and manpower by having the control for all mats be remote via our website.
Here, we have a short demo with our mat on the left and ice cubes on the right, showing the control environment. As you can see, our prototype is effective at melting thick ice cubes. Snow would melt faster. To showcase the communication between the website and our Wi-Fi module, here it is controlling an LED wirelessly.
Compared to salt, our mat is much better for the environment. What makes our design stand out amongst others is how it's turned on and off. Thanks to our mat's remote and automatic control, it would be easy to implement at a large scale, unlike existing electric mats. Thank you so much for your time.
Okay, thank you very much. 5 minutes of questions start now.
Nice. I really like the design. That's awesome. I was wondering, with your prototype, when you're showing the bottom, you're showing the heating coils underneath. Was there something to? Was there another mat that goes under that to prevent water from mixing with electronics?
I'll show you right here. As you can see, I don't know if you can see here, but we left this side open so you can see the inside a bit.
Okay.
But yeah, there's a mat below, and then there's the mat above, and in between we have padding to raise the middle to drain water.
Perfect. Thank you.
When you considered your accessibility of this mat, how strong is it? If you're having wheeled vehicles, including wheelchairs and so forth, going over it, did you give that much consideration?
Yeah, so this material is actually normally used for outside mats. We use this material because it was known to be durable. The wire inside is also very hard, and it's not very prone to damage by compression. So any compression would not cause any damage. This mat is also easily rolled up for storage or for any other uses. So yeah.
The reason I'm asking is because did you actually check the stress factors that might come from a sort of a 400-pound wheelchair and a 200-pound person in it, with most of the weight borne by two middle wheels? So that's like 300 pounds a wheel.
Yeah. We tested walking over it. We did not test very strong weights applied to it. But that would be something in the future that we would test and make sure that it would work.
Mm-hmm.
It looks like on the side where you see the mounts in the picture to the left in there, that would be a trip hazard coming on the other way. Are you planning on having like a side piece to cover that?
Yeah, actually, in fact, we just left this open for so you can see the inside, but the other sides are actually closed off and actually flow pretty flush onto the ground. So I do not think that would be a trip hazard.
So maybe just a comment, your system is so thin you might not even need to put slope on it, because sidewalks and stairs already have their own slope, which runs the water away towards a central system. Have you tested this over like steps? It seems like pretty similar to what facilities installed on campus during winter. They install carpets on the stairs going up to buildings. Would this be easily attached?
Yeah, this would be very easily attached. It is meant to be flexible, so it can be used for different applications. That was one of the design concepts that we really wanted to stress on. So yeah, it should be able to work on different steps of different sizes as needed.
And if there's a big snowfall, let's say 30 centimeters minus 20 degrees, do you think the system would be able to sustain such a big amount of snow in a short amount of time?
So the idea would be that as the snow is falling, it would melt. So it would melt a lot faster than the snow would be falling. We were not able to test with actual snow because our prototype is actually in Florida, which has obviously hindered our testing possibilities.
What's the energy consumption per square meter?
So from what we have calculated with the voltage and amp usage, it's around 21 per square foot, 21 watts per square foot, or around 65 per the size of the mat of this size, which is around 1.5 feet by 2.
Okay. That's about a third of a square meter, right? So that'd be about 180 per square meter, something like that. Okay.
Yes, that sounds about right.
And at what ambient temperature does it start to operate?
So this can actually be modified, but it's actually meant to start not by the ambient temperature, but by weather data given to us by the weather networks, local weather networks. So if it says that it's going to snow or that it is snowing, it would turn on automatically. This can be overridden by a switch on the website. But the temperature is regulated with an internal sensor so that it doesn't go too high and it constantly remains at a known temperature.
Okay, thank you very much, Group 7. That's all the time we have. Judges, you can go ahead and evaluate. And next up is, sorry, this keeps taking me a while, Group 8.
I'm done.
Me too.
Me as well.
Good.
Yeah, I'm good too.
Okay, awesome. Team 8, whenever you're ready, go ahead.
Every year, the University of Ottawa spends up to $1.5 million in snow removal fees. One of the largest contributors in this cost is salt. As you may already know, salt is a widely used method of melting snow and preventing ice formation. For residential use, it's a cheap and easy solution, but on the scale of a university campus, this cost can build up rapidly. Compounding this cost is the damage it causes to the local environment and infrastructure, which requires even more funds to protect and maintain. Our group, Hydroptimal, took on the challenge of developing a cost-effective method of snow and ice removal, and is developing Hex Heat, a modular hydronic heating system for use on campus.
The Hex Heat system takes advantage of our university's hot water distribution network, transferring its heat to the Hex Heat's glycol system, which circulates around the tiles like these, melting any snow or ice on top of it. By using the campus's hot water network, the Hex Heat system is highly efficient, drawing a maximum of 20 watts to power a small pump and the electronics, costing around a cent every 4 hours. Despite its already low power consumption, our team decided to push its efficiency even further. Using a temperature and barometric pressure sensor, Hex Heat can preheat itself when snowfall is imminent, as well as accurately determine the capacity the system needs to run at and to reduce power consumption accordingly.
The Hex Heat system is not only efficient, but it's also modular. Each tile is 6 inches across, allowing for usage in tight or awkward spaces that other products might have difficulty fitting in. The small size also lends to easy storage, allowing it to be stored in nearly any storage space. Each piece is connected by a locking bar that slots into one of the tile's 6 sides. These bars are screwed into place, ensuring a tight seal between each of the tile's pipes. These tiles are also made of thermoplastic, and as such can be easily produced using molds.
And seen here, we have a video. I'll just throw the link into the chat.
Having technical difficulties.
Here we go. I'll just put the link into the Zoom chat, and I think you should be able to just watch it there. And this is just going to be a minute-long video, which you can just kind of skip through, and it shows the roughly 35 minutes it took for the tile to melt a 1.5 inch tall chunk of ice. Yeah, so we can just kind of skip through because this one, it's a bit of a minute long, so it might be a bit long.
Okay, you've just hit 3 minutes. So I'll leave it up to the judges. If you want to keep presenting, then I can just start your 5 minutes of questions.
I think we're pretty much done, but yeah.
But so why a product? We see hydroponical hex heat as the best option in offsetting the costs and damages associated with the usage of salt and snow and ice removal. If implemented, hex heat's modularity and high energy efficiency will save millions of dollars of the university's budget in years to come. Thank you for your time, and we'd now like to open the floor to questions.
Okay, so you want about 30 seconds over for the presentation, so there's about 4 minutes and 30 seconds left for questions.
What is the size of the tile? How big it, and how do they assemble together?
So as mentioned earlier, these tiles are six inches across from one face to the other, and they're 1.5 inches in height, and they assemble together. As I mentioned earlier as well, there are locking bars that go insert into these holes here. These locking bars are then screwed in, which is how they are secured.
So the you don't have anything to anchor them to the ground. Is it just the weight of the pipes running through them that and the water that holds it down?
Yes, the current prototype only uses the weight of the tiles to keep it on the sidewalk. Yes. That's all.
Could your system be used on kind of wastewater or water that's been used in the hot water system, still contains heat and it's being discharged to the sewers?
The water we use to heat the hot water, the hot glycol, would just go directly back into the university's own hot water system to just try to recycle as much energy as possible.
Could it be used for wastewater though?
If it can be used for, I believe the term is gray water,
Yeah.
water that doesn't have any particulate material in it.
Right.
So yeah.
So that would save even more energy because it's operating right now on university heated water and putting it back in, but somewhere at the university there may be as you say, a gray water discharge. And that was my question. Could that heat be used or is it below the threshold?
That heat could be used.
Yeah. Okay.
So in terms of the surface of your models, I know you said that it's made out of thermoplastic, but the surface itself, is it anti-slip?
The surface is still made of thermoplastic, but we've designed grooves into it, as you can see from the picture in the top left, to help improve its anti-slip qualities.
Just a quick question. The module, they fit on top of a pipe that runs all the way through, or how do it, or it just fits on top like, is there an attachment between the tiles, or it's just sitting on top and then you can remove it if it breaks, or if there's a break in the water line, how do you fix it?
You can
right.
remove the tiles pretty easily
Okay.
because, yeah, so all the tiles, they can have, you can either thread the pipe through it and then just kind of take off the tiles one by one, or you can just directly remove the tiles, just pop them right off of the pipe itself. So if you can directly operate on a small piece of the pipe, or if you want, you can just take it out quite easily.
Okay.
Do you have an estimation in the cost, since it's a custom-made mold for those tiles?
We don't have a estimate for the cost of the mold, as you, but we estimate the cost for the actual tile itself to be about $18 per tile.
Okay, so that's actually right around the 5 minutes. Thank you very much. The next group will be F11.
I'm done my evaluations.
I'm also
good.
done.
Then
Done.
Yeah, I'm okay. I'm done.
Okay, awesome. And I'm ready to start timing whenever you start. F11.
Hi there, my name is Ibrahim Mertuza and I'm joined today by my colleague Cam McGregor, and we're here to bring you our version of the heated sidewalk. So let's get into it. So earlier on in the year, the University of Ottawa contacted us to solve a problem in regards to the removal of snow and ice within the campus. They told us to create a sidewalk which can melt snow and ice upon its surface. However, they gave us some requirements to follow. They said this sidewalk must also be able to expand and contract based on the length, of course, that they desire. It also needs to be able to be stored in the summer months. So another requirement would be that it needs to be small and compact and preferably easy to stack and easy to move around. And of course, last but not least, we can't forget, safety is number one first. It also needs to be safe for the people walking upon it. Some users who would want our product are any businesses or small corporations who cannot afford any permanent solutions to snow removal and wish to have a scalable walkable that can melt snow and ice. Some potential clients would be restaurants, retail stores, and of course the University of Ottawa, who gave us this project to begin with. Some other alternatives we looked at which may help solve these problems are heated mats, as you can see, and a permanent heating solutions within the concrete, as you can see on the picture on the right. However, they do not reach our clients' requirements as being scalable and storable, which I mentioned earlier, which is why we focus on the two key aspects that we attempted to solve today here with our prototype, which are scalable and storable.
The biggest difference between our product and the competition are those two aspects. Our product can be easily expandable, contractible by using heated sidewalk cells. You can attach more cells, making the sidewalk longer, or detach the cells, making the sidewalk smaller. Each sidewalk cell can be easily stacked upon one another, making storage simple for the summer months. Our product also has a removable bottom compartment, allowing technicians to look inside and change something with the electrical components if something goes wrong. Each cell also has latches on either side to ensure tight fit from cell to cell, and the latches are also covered using screws to prevent theft for the sidewalk. So as you can see in our left video, the sidewalk is plugged into the wall using a smart plug, and you can use your phone to turn it on or off. You can also set schedules for certain times or dates throughout the week and turn them on and off, or set a timer. And on the video on the right, you can see an ice cube melting on our sidewalk, slowly flowing down the side from the slight slope that we created to allow the water and ice to slowly flow down. So here is our sidewalk right here. It has a slight slope to allow the ice to flow down just like that. And here's the bottom compartment to allow all the wiring through it.
Okay, sorry to cut you off. We've just hit the 3-minute mark.
Yeah, sorry.
Yeah, judges, you can ask them to continue or just start with your questions.
I like the module idea. I don't like the storage. It's kind of difficult. Have you thought about more like a more permanent solution to leave it in place instead of removing it?
Well, the whole, like the point of this was to, I mean, I guess keep it there as long as you want, which it can just kind of like stay there and you just like attach as many as you want. But the point of it was to be detachable so that he can make it like as long or as small as he wants. So he can just take parts off and then store them, just like stack it away somewhere. So I'm not too sure exactly what your question was asking there.
Yeah,
if I answered that.
Yeah, so if a module stops working, you can easily replace it. So
yeah, exactly. Yeah.
So have you thought about just leaving it in place permanently instead of thinking about storing it out? And would this affect the type of material you would be using if you use it?
Yeah, of course.
Yeah.
Yeah. If it would be stored there all the time, it would definitely need to be a more durable material. So I guess it could technically be stored there throughout the entire year. It was just our client told us that he would like to take it out during the summer months. So that's why we incorporated that as well.
Is that going to be the final thickness of your prototype?
So it's like about this thick for, I mean, I guess this size, but realistically, this would be about 3 feet long and 1 foot wide. But the thickness really wouldn't change at all. We could probably make it even thinner because if you can see inside of there, there's a lot of just empty space. So you could probably make it another inch and a half thinner than that. It was just kind of like, I didn't really know exactly how everything was going to fit in there in the final design. So I just kind of gave it some extra room just in case.
You were saying that the length of that piece would be like 3 feet, right?
Yes.
Okay, so if I want to do something that is longer and be 2 times those modules, that would create like a swell between those 2 pieces. Is there an idea of having like a channel or something to collect the water that falls in the swell? Or how does that work?
To collect the water?
Well, if you're putting, because you have this variable profile, right? You are creating a depression in the middle when you connect more than 2 modules. What that happens with water that falls within that crack? That just like go away? Do you have a system for that?
So yes, I guess eventually it would just go away. These components aren't made to, so there would be a cover that goes on top of here to like block off the latches. The latches are made to go from this cell to the cell next to it, just like that. It's not really designed to have a cell going from here on and like beside it on this side. So I guess you could put another cell next to it. It wouldn't attach right now as it is, but I'm sure we could easily just figure out some way to attach them both and create a slight gap in between them to allow the water to like, instead of just flowing, like staying on top of like right in between them, we could have a little gap there to allow it to just to fall down underneath.
Just quick question, what's the surface material you're using for this solution?
So right now, the surface material is just this thin piece of rubber, just to allow like people with wheelchairs or crutches or whatever, just to not slip on it. Right now, this is just like a 3D printed part, so we didn't think that it would be like very like sticky. Like it wouldn't be like, it wouldn't have very much friction. So we just put like a rubber sheet on top of it just to make it a little stickier.
What's the energy utilization per square meter?
So we didn't really incorporate any really like electrical bits for this. We basically just bought a 6-foot heating cable. So that wouldn't be a permanent solution. We would obviously make more improvements with like the actual cable being inside of the actual sidewalk and not being just a normal like heated cable. I'm sure it would be a lot more industrial than that. So right now, I'm not 100% sure exactly how much electricity it would use, but on a larger scale, it wouldn't be this accurate anyways, because it would be a lot bigger and using different wiring and everything like that.
Thank you.
So, maybe another question. Have you thought about, once again, staircases, steps? How would you adapt this to a stair?
Yep. So I guess these pieces they can basically just sit on anything. So I guess staircases can be all sorts of different sizes. So I guess depending on the specific size of a staircase, we can design it to be exactly that distance and maybe have something that drops off the side to make sure that it doesn't move around and stick to the next one. So it'd be basically just like a customized design for the staircase so that it doesn't move around anywhere and still heats everything up.
Okay, thank you very much. That will be the 5 minutes for questions. And we have our last group up next, F13.
I'm good.
Yeah, I'm good as well.
I'm good.
Okay, I'm good.
Okay, F13, whenever you're ready.
Okay, sounds good. So hi, I'm Bobby Lasham, and today me and my group are going to take you guys through our design for the modular heated sidewalk. So to begin, let's start at the beginning. Let's start at the problem. So what is the problem? It may look really nice outside today, but for about 6 months every year in Canada, all the paths are covered in snow and ice. And this can cause a lot of problems in traversing these places. It's very difficult and can lead to a lot of safety concerns, such as people slipping and falling, which is something that we don't want or need. The current solution, as utilized by the University of Ottawa and many other places, is to use salt to melt the ice. But then problems come in where to lower labor costs, places are over-salted initially so that they have to come less frequently, as well as salt is very corrosive and cause a lot of structural damage to our infrastructure. And so why does this matter? Well, the University of Ottawa is a place of equity and equality, and students of all abilities need to be able to transport themselves across campus in order to learn in what feels like a secure and inclusive environment. As well, since repairs need to be done more frequently, I can speak for the students anyway, and most likely the University of Ottawa, in saying that we'd like our money to go to better places, and having to repair infrastructure as often as it has to is not as optimal as perhaps investing more in classroom activities and things of that nature. So if repairs can be done less frequently, the money can be used in better ways, save money for the university and save money for the students. So now to do this, there needs to be a better solution for snow removal, and that's where we and our product come in.
Yeah, so here's our design here. Here's the prototype. So we wanted something that was very simple, so anyone could know how to use it. So our design just has a plug and a sensor. So just plug it in to the wall, and if the temperature is less than 0 degrees, which is when the snow will fall, the heating coil will turn on and melt the snow. So to design it, we just bought a heating cable here. There it is right there. And we just snaked the heating cable through this winter hat. And then our design has bolts on it, and bore holes will be bored into the concrete where then the bolts will be bolted in. That way it is both secure so nobody trips on it, and also
no one can feel it. It having a sensor is also good for the environment. So when the temperature is above 0, the heating cable is not turned on and it's not wasting any electricity. It's also quite efficient. So when it is cold, the cable works quite well, as you can see in the photos here. And then following slide. So here's our demonstration. So Bobby, if you want to unshare, I'll share the screen.
Okay, and just letting you know, you are already at 3:15, so I will start the questions, and judges, if you want them to continue presenting, you're welcome to ask them to do that.
Oh, I think we can. Yeah, we can continue.
Yeah, it's a really quick, I'll just skip to the video. So basically we put ice. It would work even better with snow because the ice was right out of the freezer. And this was just after a few minutes. The cable also wasn't heated up because it's inside. So it really only works when the temperature is cold. So it was hot, so I had to put ice packs. So there was a bit of error there. But yeah, as you can see, the ice is melting. That's all.
Well, maybe a quick question. I saw the cable you purchased was pretty thick and the material you're using is pretty thin. So how is it with a wheelchair, or if you roll on top of it, do you feel all those bumps? Or
Yeah, so what I did is it's actually a couple layers here of mat. So what I did was I cut out a third mat in between and cut a track into it and then laid the cable inside the track so that it would all be flush. So when you're looking at it, it's actually all one layer, because yeah, I thought the same thing, you'd be able to see it. But yeah, so I put a third layer in there.
Okay, thank you.
Yeah, for sure.
So how do the mats connect one mat to the other? Does each one of them have to be plugged in, or can they be hooked together?
Yeah, so this was
go ahead. Yeah.
Prototype. So under the budget constraints, we just designed this. But if somebody wanted to take the design further, what they could do would be to add clips and be able to clip them together. And then on this other side, I left it exposed so that you could cut it off and connect it in series. For the sake of this prototype, yeah, you just plug this one into the wall. But yeah, definitely in future iterations, if someone chose to develop upon this design, then yeah, they could definitely implement that.
Where do you see this being primarily used, the greatest use? In the long sidewalks and so forth, or stairs, short spaces, special spaces?
Yeah, so the nice thing about our design is that it's simple enough that it can kind of be changed and implemented in a lot of different places. So we could definitely build this out to be like used for very long sidewalks, not only as like one unit, but in multiple units. And then as well, because it's so simple, we could design it in such a way that it would be able to fold to the contours of stairs and be used there as well. When we were aiming for this design, we definitely focused on simplicity for both the user and the design itself. So it can be implemented in a very wide range with pretty minimal, like going back to the drawing board to work with it.
And what's the energy use you envisage per square meter on this device?
So we did calculations. So it's 49 watts per square foot at the moment. That we can change that based on the layout of the cable inside. But when we were designing it, we took into account the day of heaviest snowfall in Ottawa over the last 21 years. And then we just wanted to be able to have the power necessary to melt snow on that day for like every day, so that there would essentially never be a problem for the foreseeable future. And so we got to 49 watts per square foot, and that met the metric. So that's where we stopped. But we could change it up depending on how we wanted to shape the mat.
Okay.
And how do you activate your mat? Is it on-off switch or an automated switch or what?
Yeah, so we wanted to keep it very simple. So you just plug it in all winter long, you keep it plugged in, and there's this sensor on here. So once the snow falls, like someone doesn't have to wake up at 5 in the morning and come turn on all the mats. There's no switch. The sensor automatically turns it on. So you just leave it plugged in, and then as soon as it reaches below 0 and snow has the potential to fall, the sensor will turn the mat on.
And what kind of sensor is that?
It's just a basic temperature sensor. So basically it just senses when it goes below zero, the power is applied to the circuit.
Have you thought about connecting this to an application? Like if you think about a university campus, you might have 6 million, 7 million square feet of surfaces. So how do you manage this from far away if you're home to make sure that the math is actually working? So have you thought about another system than just a sensor?
Yeah, so we were actually looking at other sensors that can be overridden and controlled as well. So ideally what we would want in a perfect world would be a temperature humidity sensor, since humidity, it can also snow if it's above zero. It's the humidity and temperature of the atmosphere that'll decide whether conditions are conducive to snowfall. And then that sensor as well can be controlled with an application. The problem is that for that, our budget was too constrained to be able to fit that in. But if we were to be granted, a little more money for our design, that would definitely be implemented. And then you'd also be able to control things from an app, turn it on, turn it off, stuff like that.
Okay, thank you very much, C13. That's the 5 minutes for questions. I believe that's all of our groups for this section. So really well done to everyone. Thank you for being prepared for your presentations. No major mess ups or issues. So great job, everyone, with that. Thank you very much, judges, for being here and listening to all of the groups present, and to the client as well, John. So the next step will be to get the judges in the deliberation room. Judges, you don't have to worry about doing anything for that. I'm just going to send a message to our TA who's in the main room, and he'll send you. And I will join you in a few moments. John, you're welcome to stay here. And if you have any questions for the groups, or if you want to talk to them more about their designs, you can stay in this room, and the groups, it seems like most of them are still here to answer any questions about that. And to all of those who are left in this room, I believe we have another TA who's in here who can help you with anything you need, or if anything comes up, you can always just hit the ask for help button and we will send one of our people in to help with whatever comes up.
I just want to say thank you to all the judges for doing this. This is really cool. Thanks, guys.
Absolutely. We're always very, very grateful when the judges come in, especially when they are as knowledgeable as you guys are. I think this is an awesome crew of judges.
Nice. And while the judges are getting ferried off to their special room where they make decisions, I just want to say hi again, everyone. Thank you, students. Great jobs. Prototypes is awesome. I know it's crazy. This must be so hard to do at a distance. Especially, I think it was one of the groups that mentioned that they're testing their product out in Florida. Like, that might be a little tougher too. Although I got to say, I am kind of liking the whole like Zoom format. I guess it's different when you're actually in the university and you can prototype inside a lab and try things out. But this is much more civilized. I do have to tell you, the way that the decisions were made in the past about who won was to simply take the prototypes and have a giant battle royale fight to the death. And really, so it was the prototype that had the hardest materials that usually won. But this is much more civilized. So I'm very happy about that. Anyone, while we're waiting for the judges to go off, does anyone have any, did anyone have any interesting stories about with their prototypes? I was deathly afraid that someone was going to catch on fire and I'd hear about it on CBC.
Actually, one of our teammates, the one that was prototyping actually I'm going to put on the camera. The one that was prototyping our prototype at first, before we got the mat and before we got any power converters or anything like that, he tried plugging it directly into the wall and it burned his floor. So that was just kind of a funny story, but obviously now we fixed that.
And it's good that you figure this out in first, second year. So it's not like working on some giant project in the future and it's like, well, we turned the city power grid on and we burned a couple of floors. So this is good.
Whoops, sorry guys, I think the TA may have accidentally moved the client. I'll ask him to move the client back. Poor John, mid-sentence.
They just put me here.